In previous couple of videos, we tried to describe a stochastic process using either distribution or some of the statistics. In some other applications, we may describe a stochastic process using other means. One example is the description of a stochastic process as an independent increment process. So let's see what is independent increment process. This is just one example of alternative description of a random process. So we call a random process as independent increment. To do that, we need to define increments of a random process. Suppose that you have x of t, this is time t, and then you take some arbitrary time instances. Let's say this is t1, and then t2 is bigger than t1, and let's say this is tn. They don't need to be uniformly spaced, just arbitrary time instances. And we define the value of x of t1, x of t2, the value at the second time, minus the value at x of t1. So this difference is the increment. And then you have x of t3 minus x of t2. So this is the next increment. And then you have x of tn minus x of tn minus 1. So how many increments we have? 1, 2, etc. So we have n random variables. So if these n random variables are independent, we call these random process for all t1. For all t1, if they are for all t1 and t2, for all t1, for all t2, and for all tn, if they are all independent for arbitrary time instances, then we call this a stochastic process independent increment. So these are the increments, and this definition makes it simple and easy to describe the distribution. As soon as we know that these guys independent, then their joint distribution is described by the marginal distribution. So if you have distribution of this guy, if you have distribution of marginal distribution of this one, instead of having complicated joint distribution, you can describe it using marginal distribution, and 1D distribution is easy. So a random process is called an independent increment process if these increments are independent for all n and for all tk. If this is only true for, let's say, n equal 3, we call it third order independent increment. So depending on your application, you may define and use whatever you need. So the PDFs of an independent increment process can be expressed by the joint PDFs of independent sequences yn, which is much less complicated and more useful.